Okay, good day everyone. My name is Dylan Hart and I'm here with my colleague Christian de Jager and Ursula Barnes from Impendulo, who is the architect on the project. Myself and Christian were both the structural engineers involved in this exciting project, which is the UJ Rescue Centre. So the UJ Rescue Centre is located at the University of Johannesburg campus and is a new, innovative standalone structure. So the project brief, the client for the project was the University of Johannesburg, with the rescue department being the end user. The architectural design and coordination was done by Impendulo Design Architects, with the main contractor being PY's Projects, and EDS Engineering Design Services was responsible for the civil and structural engineering on the project. The brief of the project was to design and build a structure that could act as a functional space for students to learn in a classroom environment as well as a practical environment. The building was to be designed to be one of a kind that included various elements to simulate real-life rescue scenarios. The main features including a wave-generating pool, internal human-rated crane with helicopter fuselages, multi-level training platforms, trench simulation, rain simulation, and many other aspects. The space provided has the following areas. So it had multi-use spaces, classroom spaces, medical facilities, offices, bathrooms and change rooms, main operational spaces, lower level basements, human-rated cranes for hoisting, as previously mentioned, and many other features. In the renders, it is clearly seen how the structural steel installation plays a major role in providing accessibility and has made a standout feature with the orange paint specification, which is also one of Ursula's favorite parts of the building. In this architectural render, you can see the external perimeter of the building, which is actually being constructed of the cantilevers from the edge with multi-level steel walkways, as well as a perimeter screen. There's access between the internal and external on every level. Structural steel was a necessity in the design to provide a lightweight installation due to the cantilever beam system below, and enabled us to reduce the design and basically minimize the capacity or lower the capacity that the beams had to carry for the upper levels.
It also provides adaptability for future walkways and or altering whatever scenario the rescue simulation requires. So if they require large platforms, other shaped platform, they can easily alter that with the steelwork. So the steelwork also helps us with adaptability of the structure as the rescue simulation would require.
Then when we get to the project overview, the project was completed in November of 2025 with the total cost of the project being just under 70.5 million, that's excluded. Then the type of the structure you'll see is a structural steel building with conventional structural steel frames. So it is a combination of a concrete frame and a steel frame, with a large component being the structural steel. The structural steel formed a large part of the architectural design and provided the aesthetics to make the structure stand out. Due to the client being the University of Johannesburg, the end use is institutional. The UJ Rescue Centre was designed and constructed as a state-of-the-art facility for the University of Johannesburg to be used to simulate a multitude of rescue simulation scenarios. The facility is one of the first of its kind in the Southern Hemisphere and houses unique features, as previously mentioned in the previous slides: the basement levels for the conducting of trench simulations, the 6-meter deep training pool with the wave generation functionality, rain simulation, multi-level platforms for rope access training, as well as the human-rated crane to hoist the helicopter fuselage and Hewitt for air rescue training simulations. So that can be clearly seen in the image that we provided in the slide. So you can see the crane beams that are resting on the corbels with the structural steel walkways along the perimeters, and then in the bottom there you can see the wave generating pool. The total cost of the structural steel, as mentioned, is 4,904,125 rand, excluding VAT, with a total tonnage of 75.89 tons. The typical sections that were used in the construction and the structural steel are typically I-beam and H-beam profiles, angles, square hollow sections, circular hollow sections, channels, and the purlins and girts being cold form lift channels. The project, a little bit further on the project overview, the structural steel was supplied by two main steel contractors, by two steel merchants, with the main steel contractor being Churchyard and Umpleby, the two merchants being Max Steel and Allied Steel Road. All structural steel was delivered timelessly to site for installation during construction. There were three different types of cladding that were used in the building facade. The roof sheeting was a 700mm cover clip-tight 0.58mm thick sheet. The side cladding was a 762mm cover new rib 0.58mm thick sheet, which both of these being installed by chart hole roofing. And the cladding used on the pop-out perimeter was an expanded aluminium that was installed by GAP. The cladding installation was completed in the month of October in 2023. And the total coverage of the cladding being 3,798 square meters. But that is for the cladding only. In the following slides, we have kept our written motivation, which was previously submitted. So the complete write-up of the project submission, included in the next 3 slides, which highlights more on the project background, the key challenges, steel selection, construction innovation, and the project significance. So we've left these slides in as requested for the judges to review. Then we move along to the structural steel or the structural framing component. As previously mentioned, EDS Engineering Design Services were the structural engineers for this project, with Churchyard and Umpleby as the main steel contractors. The steel merchants for the project were Allied Steel Road and Max Steel. The structural detailing was also done by Churchyard and Umpleby and produced the shop drawings and fabrication drawings. Therefore, the process was all handled in-house. The software utilized for the design of the structure was Tekla Structural Designer as well as Procon, with Procon predominantly being used for the structural steel designs. The structure was modeled in Tech Structures, and as you can see in the model that is shown in the slide. And then the other image that we've used here is just our steel roof general layout, which was the as-built drawing at the end of the project. So a little bit more on the structural system. The structure is a portal frame system that spans the full width of the building. The cross bracing angles were used between the rafter beams that run down into the elevations to the foundations in the concrete frame. Various profiles were used, previously mentioned, which include the I and H profiles, channels, angles, square hollow sections, circular hollow sections, cold form lift channels, etc. And specifically for the crane beams, there was a plate girder that was constructed. On the internals of the structure, there are steel walkways on multiple levels with steel staircases for access. These are predominantly constructed from channel sections and internal angles for bracing, and the walkways were also grating panels. The balustrades on the edges of the walkways are removable, which is a key feature to the building, which provides flexibility for the intended use by the client and the rescue team for training. So for instance, what they do is they go and they fasten to the structure at multiple points, and then they rappel from level to level using full access of the building, and provides them with creating very unique training scenarios. So with regards to the initial steel erection, so the images shown on the current slide provided a look into the construction process and the erection of the structural steel. A tower crane was utilized for the hoisting of the structural steel during the main steel construction period, and you can see there on the bottom left photo in action. At the top is just a kind of a panoramic of the structural steel installation. So in this image, you can see the building in its raw state with all the structural steel, so only steel before the cladding commenced. During these stages, our quality control inspections were conducted to ensure that everything was installed as per the approved shop drawings and our construction drawings. And the installation of the cladding, the perimeter walkways that later followed. So you can see in the images with the side cladding busy going up as you're closing off the building, and then the steel walkways coming in along the perimeter. The final installations to complete the building was the expanded aluminium cladding, which came on all the elevations on the perimeter walkways, which just provided that aesthetic look and feel that really makes the building stand out. Now, to focus a little bit more on the metal cladding and the roofing, so the cladding manufacturer being GRS or Global Roofing Solutions, which were also the roll former and profiler, and the contractor being Chartwell Roofing, for, as mentioned, for the roof sheeting and the side cladding, with GAP installing the expanded aluminium, and then the paintwork was done by Plascon. So to jump a little bit in, as previously mentioned, the main cladding contractors, Chartwell and GAP, and we've just gone and summarized the roof, side cladding, and aluminium cladding, which were the three types used, with the total square meterage 3,798 squares. Now, we've also gone and just listed the full cladding specifications, which I'm not going to dive too much into detail, but you can just see with regards to the colors and the galvanized steel that was used, with the charcoal gray and pebble gray backing coat for both the roof and the side cladding, with the feature cladding being the expanded aluminium. On the side, there's a beautiful image extracted from the architectural drawings, or showing the one elevation actually indicating the side cladding and then the expanded aluminium. And then in these images, you can see the final installations. Upon completion, the external aluminium cladding provides the following functionality along the building perimeter, and that includes it provides a multi-level effect on the structure, so you can actually see through it as transparent, and is able to provide natural light along these walkways, and also provides airflow along the perimeter, so you don't really feel congested or claustrophobic walking in the tighter spaces along the perimeters. Then the fabrication, that was now done by Churchyard and Umpleby, also known as Can-Do. So the structural steel for the UJ project was completed in September of 2023 with a total tonnage of 75.89 and a total cost of 4,904,124 Rand. The main steel contractor, Churchyard and Umpleby, also known as Can-Do, is actually their workshop is located in Glencoe, KwaZulu-Natal, and therefore all the structural steel was manufactured in KwaZulu-Natal and transported to site in Johannesburg. It was therefore imperative that all the planning and design was done to ensure that no delays were encountered in this process. In the slide, you can see the shop drawings. As previously mentioned, Churchyard and Umpleby were also responsible for doing the shop drawings, which we assisted by providing our Tekla 3D models, which made the process quite smooth and seamless. So yes, for them, the whole process was executed in-house. All the structural steel was methodically fabricated as per the reviewed and approved models and packs. In the slide, you can see when the steel was actually the fabricated steel that has been painted and delivered to site. So it was all transported in batches as the site installation progressed. Then for the erection, construction and installation, yet again, Churchyard and Umpleby being the main contractor. So for the steel erection, the facts that we can draw from there is the total tonnage of the structural steel, 75.89 tons. They used one tower crane during the erection process. And a big key factor in the erection process was there were issues with regards to concrete tolerances during the construction period, and the structural steel was actually modified to accommodate for these tolerances and manufactured before being brought to site. So you can see the photo of the tower crane. So the position was optimized so that it could reach the laydown areas of the structural steel, as well as being able to rig the full building which was a very optimal solution and minimized the cost of the project. And fortunately, due to structural steel being very quick to erect, the laydown of the structural steel was for a very short period. Then in these two images, you can just see the installation that was taking place on the perimeter beams, which cantilevered off the side of the building. So you can see the subframe going up there, which supported the expanded aluminium cladding, as well as the walkways along the perimeter of the structure. Moving on to the challenges and the solutions. So to summarize, there were, let's say, 4 to 5 main challenges that faced this project. So the project started in 2020, which is a year filled with issues and delays due to the COVID-19 virus. There are many safety restrictions due to the outbreak, with limited and hindered productivity. The second main issue was actually the main contract. The initial main contractor was actually fired due to being late on the project by approximately 120 days in their program. And PY's projects took over as the new contractor. When PY's project took over, it was seen on site when a survey was done that there were concrete tolerance issues, which had to either be corrected by concrete remedials or adaptations of the structural steel. Structural steel being so versatile, it was the better solution to go and adapt to be able to accommodate the concrete, but there were compromises made on both sides. But that project, due to the survey, that process moved relatively easily. And yeah, the other issue being the human rating of the crane. So Ursula, I know, can definitely elaborate a lot on that, but there was a rigorous process that took almost over a year to get the human rating in order to operate the crane within the building, and it pushed out the final completion of the project. And the benefits of structural steel in this application. So list of benefits. There are many benefits of utilizing structural steel in the UJ rescue building. Due to the nature and use of the building, the perimeter walkways provide full access for the training exercises, as previously mentioned. The removable handrails allow flexibility on those training simulations. The grating that was used for the walkways mitigates the ponding water due to the use of rain simulations within the building. The structural steel construction component was the fastest installation during the construction, which obviously assisted with program and timelines of the project. And the structural steel profile provides less bulk within the operational space of the building. So due to the use, you want more space to be able to conduct more activities, and the structural steel definitely benefits in this situation. And then, yeah, quality assurance, sustainability, and efficiency. So the quality control process for the UJ project were followed throughout the whole project by means of inspections and approvals. All the guarantees for the roof sheeting, cladding were provided upon the closeout of the project. And on sustainability and efficiency, the structural design of the steel was done effectively to minimize tonnage, which is sustainable as well as favorable to the client in terms of project cost. The expanded aluminium cladding minimizes the maintenance of the external perimeter of the building. And the use of the grating panels on the external walkways allowed for the support structure to be designed as lightweight with smaller steel sections. By utilizing structural steel in the design, the overall loading of the structure was minimized. This results in less concrete use and smaller carbon footprint. So what we are proud of in the project is the UJ project is truly a unique building, stands out on the campus. It is not just a typical warehouse structure, and there's a lot of functionality that can only be seen when it is being used. The functionality that the structural steel provides, the uses of the building are multiple and have been mentioned a few times. The crane beams for the helicopter training, HUIT training, the external walkways for full access on multiple levels, removable handrails for accessibility on the training sessions, the grated platforms for the rain simulations, and many more uses. The facade, structural steel, and the cantilever beams, and the multiple level walkways is truly a great design and brings so much aesthetic appeal to the structure, as well as being functional. The fact that the project was completed with all the challenges and setbacks does make it stand out as a great achievement. The real-world simulations that the University of Johannesburg training team cannot create will only better prepare the students for the future. I've just got a little video that I'd also just like to share. So I want to see if I can pull that up. Let's just escape there. I'll just need to go. Yeah, it is, but I just need to share. Yeah. Screen. Share. So this is a video that was provided by Ursula and her team with regards to the rendering of the building.
And I must say, what was produced relative to the rendering is almost spot on. It's truly, the design came out as it should have been.
Yeah, we're quite proud of that actually.
Yeah. Okay, perfect. But thank you so much for listening to our presentation.